Hi, my name is Vyomsekhar Singh and today we will be discussing the physics paper of JEE Mains 2016. It's code E that we are going to discuss. The first question, as you can see, it belongs to the chapter errors in measurement. The time period of a simple pendulum has been measured 4 times and the least count of the clock to measure it was 1 second. The values are given. Obviously, the best value to report would be their arithmetic mean. So, the value to report is 90 plus the second reading is 91 second, the third reading is 92 second and the fourth reading is 95 seconds divided by 4, which comes out to be exactly 92. So, that will be the reported value. Then now if we come to the individual error, in the first measurement the measured value is 90 and the mean value which we are reporting as the correct value is 92. So, what is the error? Delta t is equal to the reported value is 92 and the measured value is 90. So, the error is the measured value minus the reported value, which would be equal to minus 2. Well, if you follow the same step for the second measurement, then it will come out to be minus 1 seconds, for the third measurement 0 and for the fourth measurement it comes out to be plus 3 seconds. To find the error in our measurement, what we will do is we will first square these and then we will take the mean and then we will take the square root. That is the convention. So, we will have the error is equal to under root of minus 2 square, which is 4, plus 1 square, which minus 1 square, which is 1, plus 0 square, plus 3 square 9 divided by 4. So, that comes out to be under root 3.5, right. The value will come out to be close to 1.9, right. I would say it is closer to 1.9 than 1.8. And now, if you look at the options, we have an option of 92 plus minus 1.8 and there is another option of 92 plus minus 2 seconds. So, which option should we go for? Should we go for 92 plus minus 1.8 or we should go for 92 plus minus 2? Well, here we must keep in mind that the least count of the device is just 1 second. So, it can never give you a precision of 1 point something. So, we have to round it off and it becomes 2. The correct answer is 92 plus minus 2 seconds. So, question number 2, this is from the chapter rigid body dynamics and it is about angular momentum, as you can see. We have a particle which is moving along the path A, B, C, D, A with uniform speed v. So, obviously, the motion is confined to the xy plane and we have options regarding the angular momentum about the point O. So, what will be the formula for angular momentum? L equal to R cross P. So, this is the formula that we have to use. And suppose we first calculate the angular momentum when the particle is moving from A to B. Then when you are going to do R cross P, well, it is simply going to be momentum into this perpendicular distance. This perpendicular distance comes out to be, well, this is given as R and the angle is 45 degree. So, this distance is R by root 2. So, the value of angular momentum when the particle is moving from A to B is simply momentum, which is m into v into the perpendicular distance, which is R upon root 2. Now, let us come to the direction. Angular momentum about point O, if you do R cross P, then you can see that it is clockwise. So, the direction is along minus k cap, clockwise, inward. So, that is minus k cap, minus k cap. Now, if you look at the options, first option is the expression for angular momentum when the particle is moving from A to B and it is exactly correct, right. And obviously, you have to notice that in this case we are not to find the correct statements, we have to tick the incorrect statement. So, we have to move to the next one. When the particle moves from, let us say, B to C and we are doing the same thing r cross p. Well, you can see that if you do r cross p for this, it is simply going to be the momentum into this perpendicular distance, and this perpendicular distance is r by root 2 plus the side of the square, which is a. So, the angular momentum magnitude comes out to be mv into r upon root 2 plus a. Now, let us come to the direction. Well, r cross p, my mistake, this is r cross p. If you see r cross p, the direction comes out to be anticlockwise. Anticlockwise means the direction is out of the plane, which is k cap. So, for B to C, this should be the angular momentum. Well, B to C, this is the option, mv r by root 2 plus a k cap. So, the given option is again exactly correct. Again, this is not the answer because we have to find which is the incorrect statement. So, we will move to now option when it moves from C to D. So, again if when it is moving from C to D, you can see you can see that P into this perpendicular distance. Now, again the perpendicular distance is, well, r by root 2 plus a, and let us see the direction straight away. It is r cross p is anticlockwise out of the plane, that is plus k cap. So, angular momentum is going to be m into v into the perpendicular distance, which is equal to r by root 2 plus a, and the direction was plus k cap. Well, C to D, we have that option in 2. The given value is mv r by root 2 minus a k cap. So, obviously that is an incorrect answer. So, 2 is your answer. But then in this question, if we just solve the angular momentum from D to A, you will find that in this case when it is moving from D to A, again this would be the perpendicular distance, this is the perpendicular distance r cross p. So, p is same mv and the perpendicular distance is r by root 2. So, angular momentum magnitude is m into v r by root 2. And what about the direction? Now, if you are going to do r cross p, it is going to be clockwise, that is inward inside the plane of the paper, minus k cap, minus k cap. Well, which option covers D to A? Option 4, and the given value is mv r by root 2 k cap plus k cap. So, this is obviously an incorrect answer. So, we have 2 incorrect options in this question, 2 as well as 4. Well, let us hope the JEE mains, the exam committee is fair, right, and in that case the answer for this question should be 2 or 4, which means that if you have ticked 2, you should get full marks. If you have ticked 4, you should get full marks. Question 3, this belongs to the chapter work, power, energy, though obviously concept of friction has also been used. We have a particle point mass released from rest at point P, and it is said that the coefficient of friction for the entire path, that is from P to Q to R, is same mu, and the particle once released at P comes to rest exactly at R. Then it is said that in moving from P to Q, the amount of energy lost and the amount of energy lost in moving from Q to R is exactly same. Here you must understand that when they talk about energy lost, well, it is to be interpreted as loss of mechanical energy obviously into heat. So, what will be the loss of mechanical energy in moving from P to Q? Obviously negative of work done by friction, and similarly what will be work done by what is the loss of mechanical energy moving from Q to R? Again negative of work done by friction, which means that work done by friction in moving from P to Q and work done by friction in moving from Q to R is exactly same. Now, suppose the distance from Q to R is x dash and the length of this base is x. Obviously, what will be the value of x? X is equal to, we know the height is given, height is equal to 2 meter, right. So, you can easily find the value of x. X would be equal to, well, the relation between them would be tan 30 is equal to 2 divided by x. So, you have x equal to 2 root 3. Well, now what will be the work done by friction in moving from P to Q? P to Q. Well, the force of friction is mu mg sin mu mg cos theta. Well, the normal is going to be cos theta. Well, if you simply draw a simple FBD, you can see that the component of mg along the incline is mg sin theta, and in the perpendicular direction is mg cos theta, normal and friction. So, it should be very straightforward to see that normal is equal to mg cos theta and the friction here is kinetic. So, the value of friction is mu into n, which is mu mg cos theta. Work done in moving from P to Q is simply mu mg cos theta into PQ, obviously with a minus sign. And what is the value of PQ cos theta? Well, PQ cos theta is nothing but x. So, this is equal to minus mu mg x. Now, what will be the work done moving from Q to P? It should be straightforward. Normal is mg, friction is mu mg, and the distance travel is x. So, work done by friction there is going to be minus mu mg x prime. That is x prime is the distance travel in moving from Q to R. And as we saw, the work done by friction in the path PQ and in the path QR is going to be exactly same. So, well, these two are equal, which gives you x dash equal to x, which is equal to 2 root 3. So, now if you look at the options, he is asking you the value of coefficient of friction and the distance QR. So, what is the value of the distance QR? The value of the distance QR we just saw is equal to 2 root 3, and the closest option you can see is equal to 3.5 meter. Now, there is only one option which has 3.5 meter. If you wish, you can obviously put this value back in the original equation and find the value of mu, right, but otherwise the question is over, right. But here obviously we will find the value of mu, for which we will write the equation of work energy theorem in moving from P to R. So, we are writing work energy theorem from P to R. So, it will be work done by friction plus work done by gravity. Normal is not doing any work. So, these are the only two forces which are doing work, is equal to change in kinetic energy, and initial kinetic energy is 0, final kinetic energy is 0. So, change in kinetic energy is 0. Work done by friction, well, work done by friction in moving from P to Q and in moving from Q to R, which we have already seen, is equal to minus mu mg into 2x, which is 4 root 3. I will put the value directly, 4 root 3, plus work done by gravity. Well, the force is mg and the displacement in the direction of mg in moving from P to R is simply 2 meter mgh. So, it is plus mg into 2 is equal to 0. So, from here you can see that you just simply cancel out mg, you will get mu equal to 1 by 2 root 3. So, the correct option for this is in this code option 3. Question number 4, another very simple question from work, power and energy. A person is trying to lose weight by burning fat, and this is doing by lifting a weight of 10 kilogram up to a height of 1 meter multiple times, 1000 times to be more precise. In this process, well, all the assumptions are very clearly mentioned. He has mentioned that considering the work done only when the weight is lifted up. So, we will assume that this person is burning fat only when he is lifting up the weight. The amount of fat which he will burn for this much amount of energy obviously is 1 kilogram, and efficiency is given. It means for Q amount of energy which he gets from fat, only Q into efficiency times the energy will be converted to mechanical energy, which he will be using to lift the weight. So, what is the mechanical work required to lift that weight for 1000 times? In fact, for one time it is simply going to be mgh, and if you are going to lift it for n times, it is going to be mgh into n. So, this is the amount of mechanical work that he has done. To do this amount of mechanical work, how much heat he must burn? Obviously, he must burn heat which is equal to this divided by efficiency. This much heat is used up. So, we have to find the mass of fat which will burn to give this much of heat. Well, it is given that 1 kilogram gives a heat of 3.8 into 10 to the power 7 joules. So, the mass which will give a heat of this much would be obviously equal to, well, first we will find the value of this term mgh into n. M is 10 and g is 9.8, h is 1, divided by efficiency is 0.5. So, the amount of heat which he has produced by burning fat is equal to, well, if you just do the calculation, it will be 9.8, efficiency is not 0.5, it is 0.2. So, it is 9.8 into 50, that is equal to 4900. So, 4900 joules of energy he has got by burning the fat, and he gets 3.8 into 10 to the power 7 joules of energy by burning 1 kilogram of fat. So, the mass of fat he has burned is simply equal to 4900 divided by 3.8 into 10 to the power 7 joules. The closest option comes out to be 12.89 into 10 to the power minus 3 kilogram, that is 4 is the correct option. So, question number 6, it is another very simple question from gravitation. A satellite is revolving in a circular orbit around Earth with h being very small compared to r. It means that the orbit of satellite is very close to the surface of Earth. And what is the minimum velocity which we must impart so that it will escape the gravitational field of Earth? Now, see, look at the language. What he is asking is minimum increase in orbital velocity required so that it can escape the gravitational field of Earth. Now, you know that if it is moving in a circular orbit, in a orbit very close to Earth's gravity, you can do a simple calculation. The centripetal force mv square by r is provided by the gravitational force, which is g mm divided by r square. So, this gives you the orbital velocity is equal to under root g m divided by small r, which would be equal to under root g r, right, where I have used that this r is very close to h. I know most of you would simply remembering the formula, you can just directly use it. Then what is the minimum velocity needed for it to escape Earth? Well, you know, it is escape velocity, and again, like if you do not remember the formula, you can obviously calculate the escape velocity, that what is the minimum energy required to get free from the Earth gravitational field, 0. So, the kinetic energy is half mv square and the potential energy is minus g mm divided by r equal to 0. This gives you the escape velocity equal to under root 2 g capital M divided by r, which is simply under root 2 small g into capital R. Again, I have used the fact that capital R is very close to small r. This I have used here in this step, and well, I know that most of you would obviously remembering this formula. So, what is the increase in velocity? This is the velocity that the satellite has, and this is the minimum velocity that is required. So, obviously, the increase in velocity is the difference, which is equal to under root 2 g r minus under root g r. Option 4 is the correct answer. Question number 7, it is from the chapter thermal expansion. We have a pendulum clock which loses 12 seconds a day at 40 degrees centigrade. What do you mean by clock losing time? It simply means that the clock is running slow. It slows down by 12 seconds every day. Then the same clock at 20 degrees centigrade gains time, right, it gains 4 seconds every day, which means that it will become fast by 4 seconds every day. Now, obviously the examiner is asking you to find what is the temperature at which the clock will keep correct time and the coefficient of thermal expansion. T equal to 2 pi under root L by G. All of you are aware of this formula for calculation of time period of a simple pendulum. Now, in this question, L is varying because of different temperatures. At different temperatures length will be different, but as far as G is concerned, it is a constant. We are not moving the clock from one point of earth to another, or we are not increasing the height or depth. So, there is no question of G changing. We can treat G as a constant. So, you can see that T is some constant into root L. Take log on both sides and a simple differentiation will result in delta T by T equal to half delta L by L, and delta L by L would be equal to alpha delta theta, where alpha is the coefficient of linear expansion and delta theta is the change in temperature. So, just notice, if change in temperature is positive, the time period increases, very obvious. Change in temperature is positive, increase in length, time period increases. If change in temperature is a negative term, decrease in length, delta is a negative term and delta T will also be a negative term, time period will decrease. Now, what about time kept by the clock? Is it same as the time period of the clock? Not at all. Time kept by a clock, it will be inversely proportional to the time period of the clock. Well, you can easily understand it by thinking it this way, that if what will happen if the time period increases. If the time period increases, then the same duration of time is recorded as less number of oscillations. So, the time kept by the clock is less, and if the time period decreases, then in the same interval of time the number of oscillations will be more. So, recorded time will be more. So, from here again another simple differentiation will give you delta T by T is equal to minus delta capital T by T, which is equal to minus alpha by 2 delta theta. We will just put values. In the first instance, there is a loss of 2 seconds per day, which means delta small t is minus 12. So, delta small t in the first instant is minus 12, divide by t is 1 day, minus 12 second, divide by 1 day equal to minus alpha by 2 into delta theta. What is delta theta? Change in temperature, final temperature minus initial temperature. Final temperature obviously is 40 degrees centigrade and initial temperature, let us assume, is theta naught, and this is the temperature at which the clock is going to give you correct reading. So, we are assuming that the temperature at which correct reading is given to us is theta naught. Now, if you write the same equation for second instant, now plus 4 second, there is a gain of time here, divide by 1 day is equal to minus alpha by 2, and now the final temperature is 20, initial temperature is theta naught. Just divide these two equations, minus 12 divided by 4 will give you minus 3, and well, seconds and days they are all taken care of in this division, and minus alpha by 2 will simply cancel out. So, minus 3 equal to 40 minus theta naught divided by 20 minus theta naught. Simple algebraic manipulations and you will get theta naught equal to 25 degrees centigrade. The question is over because there is only one option in which you have 25 degrees centigrade. Obviously, if you want to calculate the value of alpha, all you need to do is put this value in one of these equations and you will get the correct value of alpha, but there was obviously no need in this question. 1 is the correct option. Question number 8, it is a question from thermodynamics. A gas undergoes a quasi-static reversible process in which its heat capacity is constant and the pressure and volume in that process follows this equation. So, you can very clearly see that it is a quasi-static process. He wants you to find the value of n, the quasi-static coefficient, in terms of C, the heat capacity of that process, Cp, the heat capacity for a isobaric process, and Cv heat capacity of a isochoric process. So, well, you have Pv to the power n equal to constant. The formula for heat capacity in a polytropic process is R plus R by 1 minus n plus Cv. I hope all of you are aware of it. Otherwise, you should obviously you have to calculate this formula inside the examination hall. We will assume that you know this and we will proceed from here. So, that gives you C minus Cv equal to R divided by 1 minus n. 1 minus n equal to R divided by C minus Cv. So, you have n is equal to 1 minus R divided by C minus Cv, which is equal to C minus Cv minus R upon C minus Cv. You can say that Cv plus R is Cp. So, that is equal to C minus Cp divided by C minus Cv. So, obviously 2 is the correct option. Question number 9, another question from thermodynamics. The process AB is given to you and he is asking you what is the maximum temperature during the process. If you notice, as we are moving from A to B, pressure is decreasing, volume is increasing, and you know the temperature will depend on the product of pressure and volume. So, well, out of those two quantities, one is increasing, the other is decreasing. What happens to the product? The standard way of doing this question would have been to be able to write the equation of this straight line. If you write that, you will be able to express pressure in terms of volume, and then you just do PV equal to nRT, and you will find that temperature is a function of volume, dt by dV equal to 0 will give you the answer. But I would not advise that in this question, because you can see that there is symmetry. The pressure in moving from A to B, the variation in pressure is between P naught and 2 P naught, the variation in volume is between V naught and 2 V naught. So, it is very straightforward to see that the product of pressure and volume at point A and at point B will be same. The product here is 2 P naught V naught and the product here is also 2 P naught V naught. So, both of them obviously are going to lie on the same isotherm. Now, if I draw another isotherm at a higher temperature, you can see that, well, these 2 points obviously lie on the same isotherm. If I say this point is A prime and this point is B prime, so it should be very clear that in moving from A to A prime the temperature is increasing, and moving from B prime to B the temperature is decreasing. So, it should be straightforward for you to see that the isotherm for which the line AB is a tangent, the point where the isotherm is the tangent would be the point where the temperature is maximum. From symmetry, this point corresponds to the mean of V naught and 3 V naught, that is equal to 3 V naught by 2, and well, this point corresponds to 3 P naught by 2. So, at this point, if I write the equation of state PV equal to nRT, you have P is 3 P naught by 2, V is 3 V naught by 2, PV equal to nRT, and this is the maximum temperature which is being desired in the question. So, you have T max equal to 9 P naught V naught divided by 4 nR, that is option 1 is the correct answer. Question number 10, this question is from chapter SHM, simple harmonic motion. So, particle performs SHM with amplitude A, and when it is at a particular displacement from mean position 2a by 3, its velocity is trebled. What is the new amplitude? So, let us first find its velocity when it is at that particular distance from the mean position. We will use a simple formula, v square equal to omega square a square minus x square. In this question, x is equal to 2a by 3. So, if you just put that value, you have v square equal to, or rather v equal to omega under root a square minus 2a by 3 whole square, that is equal to omega a root 5 divided by 3. So, when the particle which is doing SHM of amplitude a is at a distance of 2a by 3 from the mean position, its velocity is omega a by 3 root 5. This velocity is trebled. So, what is the new velocity? The new velocity v prime is omega a root 5. Now, notice that if the velocity is trebled, what will happen to omega? Nothing. Omega will remain same, but obviously the amplitude will change. Now, at this instant, the displacement still is given by 5a by 3. The angular frequency of SHM is same omega. So, how do you find the new amplitude? Well, we will use the same formula again. V prime square equal to omega square a prime square, where a prime is the new amplitude, minus x square, which is 5a by 3. Sorry, it is not 5a by 3, 2a by 3, 2a by 3 whole square. Put values. V prime square is omega square a square into 5 equal to omega square a prime square minus 4a square divided by 9. So, well, omega square simply cancels out, and you have a prime square is equal to a square into 5 plus 4 divided by 9, that is equal to 49 by 9 a square. So, of course, a prime is equal to 7 by 3 a. 4 is the correct answer. Question number 11, it is a question from string waves based on velocity of string waves in a string. We have a uniform string length 20 meter suspended from a rigid support, and a short pulse is introduced at the lower end. It travels up towards the support. Find the time in which it will reach the support. So, this is where the pulse is created and it will reach up. Suppose at a given instant the pulse is at a distance of x from the bottom. So, at this instant, what will be the velocity of the pulse? Well, velocity of pulse at this point will depend on the tension at this point. What is the tension here? Tension there is equal to weight of this part, which is mg x divided by L, where m by L is the mass per unit length of the string. So, m by L into x is the mass of this part into g, that is the tension there. So, what is the velocity of the pulse there? V under root t divided by mu. Well, this mu is nothing but m by L. So, V equal to under root g x. Of course, now what you can do is you can know the value of V as a function of x, and you can write t is equal to dx divided by V integral to find the time taken by the pulse to reach to the top. Or even better, you could have noticed that this is of the form of V square equal to gx. Well, have you encountered that kind of equation before? Yeah, V square equal to 2gx is the equation of a body under free fall. So, you could think that this pulse is under free fall, but the fall is not in downward direction, the fall is in upward direction, and the acceleration is not g but g by 2. So, using that you could have a straightforward written that s, which is 20 meter, equal to half a is now g by 2 into t square. Now, from here you can say that t equal to root 8. This is your answer. So, question number 12, this is the question from electrostatics, to be more precise Gauss law. The region between two spheres, one sphere of radius a and the other sphere of radius b, this region, right, this region is filled with charge, the density of which is given by rho equal to a by r, where r is the distance from the center. So, obviously non-uniform density of charge is there. At the center, common center of the two sphere, there is a point charge q, and it is said that the electric field in the region between the spheres is a constant. Well, we need a bit of interpretation for this, because I would not say that the language is precise. What he's trying to say is that the magnitude of electric field everywhere in this region is constant. That is what we will understand from the language. Well, let us assume a spherical cell at a distance of r from the center, and if the electric field here, if we have to calculate the electric field here, then we will obviously use Gauss law. Using the spherical symmetry, we would say that well, everywhere the electric field is perpendicular. So, the flux through the surface is going to be E into 4 pi r square. This would be equal to the enclosed charge in this region divided by epsilon naught, or this term into epsilon naught would be equal to Q enclosed. What is the value of Q enclosed? It is going to be capital Q plus the charge in this shaded region. How do you calculate the charge in the shaded region? So, well, this I will write Q plus Q shaded. Now, Q shaded is simply equal to 4 pi r square dr into charge density rho integral. I hope it is clear to all of you. 4 pi r square dr, well, that is the volume of a small spherical cell of radius r of thickness dr. Rho is given as a by r. So, if you just put here, this term would be equal to 4 pi a, and well, the limit here goes from a to r. So, a to r, right, into well, you have this is 1 by r. So, you have r dr r square by 2, that will make it 2 pi a r square minus a square, that is the charge within the shaded region. If we put this back here, you have epsilon naught into E into 4 pi r square equal to capital Q plus 2 pi a into r square minus a square. Now, as we discussed earlier, what the examiner means by E is constant in the region between the sphere, we will interpret that the magnitude of E is same everywhere. If the magnitude of E is same everywhere, it means that E is independent of R. So, from here let us have a look. E is equal to, rather, 4 pi epsilon naught into E is equal to, you have Q minus 2 pi a square into A divided by r square plus 2 pi a. Now, this term obviously is a term which depends on r, but E does not depend on r, which means that this term must be 0, which gives you the value of A as Q divided by 2 pi a square. Option 1 is the correct answer in this question. Question number 13, it is essentially a question from the chapter capacitors, though obviously a little bit of concept of electrostatics is also being used. We have a combination of capacitors, it is set up as shown. The magnitude of electric field due to a charge Q at a distance of 30 meter from it is. So, the formula is simply KQ divided by R square, but what is the value of charge Q? It is having charge equal to sum of charge on the 4 mu f and the 9 mu f capacitors. 4 mu f and 9 mu f capacitor. So, if the charge on 4 mu f capacitor is Q1 and the charge on 9 mu f capacitor is Q2, then this charge capital Q is equal to Q1 plus Q2. So, obviously, the required electric field E is K Q1 plus Q2 divided by R square, where R is given as 30 meter. So, all we need to do is find the value of Q1 and Q2. Now, if you look at this combination, you can see it is an ideal cell. Even if it was not an ideal cell, in steady state there will not be any current, and the potential difference between these 2 points is going to be obviously 8 volts. Now, if I just look at this branch, in this branch what is the effective capacitance? 3 mu f and 9 mu f in parallel, that is 12, and 12 mu f and 4 mu f in series, that is 12 into 4, 12 into 4 divide by 12 plus 4. So, that is equal to 3 mu f. So, we have here a 3 mu f capacitor connected across a potential difference of 8 volt. What will be the charge into the combined system? It is going to be 24. So, the charge which is flowing here is obviously 24, that gives you Q1 equal to 24 microcoulombs. How will this charge be divided into these two capacitors? In the direct ratio of capacitance, that is in the ratio 1 is to 3. So, if you divide 24 in the ratio 1 is to 3, it will be 6 and 18. So, what is Q2? Q2 is 18 mu coulomb. So, capital Q is Q1 plus Q2, that is equal to 42 mu coulomb. Just putting the values here, you will get E equal to K, which is 9 into 10 to power 9 into Q1 plus Q2 is 42 into 10 to power minus 6 divided by R, which is 30 square. Simple calculations will give you the answer, 420 Newton per coulomb. Question number 14, it is a question from current electricity. All of you might remember the formula for the resistivity of a material, Me divided by Ne square tau, mass of electron divided by number of charge carriers per unit volume, electronic charge square, average relaxation time. Well, mass of electron, electronic charge obviously is a constant. You can see that rho will depend essentially on N and tau. Now, average relaxation time will decrease with increase in temperature, both in metals as well as non-metals. The reason is very simple. If you increase the temperature, then the ions in the lattice in case of metals and the atoms in the lattice in case of non-metals, they will be vibrating with a greater amplitude. So, any free electron which are present there, they will have a smaller volume to move freely. So, collisions are more likely, the time between successive collisions will decrease. So, as temperature increases, tau decreases in both metals as well as non-metals. Now, if we talk about N and we are talking about this temperature range, which you can see is from room temperature to a slightly higher temperature. At room temperature, almost 99.99% of the valence electrons in a metal are free. So, even if we increase the temperature, the fractional increase in the number of free electrons is negligible. So, we can say that for metals N is almost a constant, which means that for metals N is a constant, tau is decreasing. As temperature increases, what will happen to rho? Rho will increase. So, for metals, rho increases with increase in temperature. Now, if you look here, we have copper and undoped silicon. Undoped silicon is a non-metal, that is how we are going to regard it, and copper obviously a metal. For copper, as the temperature increases, the resistivity increases, so obviously resistance is also increasing. Now, if we come to silicon, N at room temperature will exponentially increase with temperature. True that tau is decreasing, but the exponential increase in N is obviously going to overwhelm that. So, overall what happens to this term? This term exponentially decreases with temperature. So, for non-metals, rho decreases, metals rho increases, non-metals rho decreases. How does rho increase? Linearly, because it is only because of the linear change in tau. Well, what kind of decrease in non-metals? Exponential, because of the exponential increase in the number of N. Correct answer is option 3. For copper, resistance linearly increases, for silicon resistance exponentially decreases. Question number 15 is a question from magnetic effect of current. Two identical wires A and B, each of same length L, and they carry the same current I. Wire A is bent to form a circle of radius r. So, this is wire A. If the radius of the circle is r, obviously the length, which is the perimeter, equal to 2 pi r. Then wire B is bent to form a square of side A. So, wire B is bent to form a square of side A. So, the perimeter of this is equal to L, L equal to 4A. If BA is the field at the center of the circle A and BB is the field at the center of the square B, find the ratio BA divided by BB. What will be the field at the center here, BA? Well, the formula is simple, it is equal to mu naught I divided by 2R. Well, standard formula, all of you are supposed to remember it. What is the value of R here? R is equal to L divided by 2 pi. So, that is equal to, if I put L divided by 2 pi, it is mu naught into I into pi upon L, that is all for BA. As far as the field at the center of square is concerned, well, we will draw the perpendicular on it. Let us say we will calculate A only because of this wire, and it is very straightforward to see that the field because of all the 4 wires here will be in the same direction. So, whatever the field because of this wire, the net field here is going to be 4 times that. First we will calculate the field here because of this wire. So, this distance is A by 2, and well, obviously if I talk about these two angles, both these angles are 45 degree. What is the formula for the field here? The formula is mu naught I divided by 4 pi into this perpendicular distance, which in this case is equal to A by 2 into sin theta 1 plus sin theta 2, that is sin 45 plus sin 45. So, this is the field at the center because of just one wire, the net field is going to be into 4. So, this is going to be the value of BB. So, what is the value of BB? If you just do the simple calculations here, you will find it is equal to mu naught I. Now, well, I will just cancel out this 4 and this 4, and this term is equal to 1 by root 2 plus 1 by root 2, that is root 2. So, mu naught I divided by pi A into this 2 will go up to root 2. So, what is the value of BA divided by BB? BA divided by BB is equal to mu naught I pi divided by L divided by this term. So, that is mu naught I pi upon L into, here you have mu naught I 2 root 2 divided by pi into A, and what is the value of A? A is equal to L divided by 4, L by 4. Simple calculation, this comes out to be pi square divided by 8 root 2, 4 is the correct answer.